Assalamualaikum. My name is Shazana Amira binti Subri and my number is 01 DDT20F1050.
My name is Nuraidah Iwani binti Muhammad Ruzaman. My metric number 01 DDT20F1063.
Hi, my name is Nur Fazila binti Zamzuri. My metric number is 01 DDT 20F1044.
What is minimal spanning tree? A spanning tree with a sign y less than or equal to y of very possible spanning tree of y connected and undirected graph G. It is called minimum spanning tree, MST. A y of a spanning tree is the sum of all the smallest possible sum of y of its edges. No circle allowed. Circles mean the nodes are connected by more than one edges. Technique Kruskal algorithm. Step 1. Pick out the smallest edges. Step 2. Repeat step 1 as long as the edges selected do not create a circle. Step 3. When all nodes are being connected, you are done.
First question. Minimum spanning tree using technique Kruskal algorithm. The first thing we have to do is keep including minimum edges as long as no circle is generated. So let's start. We have minimum edges here which is 1. So I include these two vertex Abiko to Moria. Now we have 1.2 here and here. So I include Mitaka to Nerima first and Nerima to Habashi. Then I have edges 1.3 here and I connect Moria to Tachikawa. Next, edges 2. I include Noda to Haruma. So edges 2.3 here and here. I draw Nerima to Noda first and Yokomaha to Haruma. Next, 2.4. I include edges Habashi to Abiko. Next, 2.5. Now, can I connect this? No, because when I include Tachikawa to Yokomaha, it will make circle here. Then, I have 3.3 here, so I draw Noda to Yamato. So now, we have connected all vertex in this graph, so we stop. After we connect all the vertex, so we have to redraw all the connected edges like this. Now we make table to calculate all value edges like this. Enter the all name of vertex and their value. Then we add all the value to get weight. 1 plus 1.2 plus 1.2 plus 1.3 plus 2.0 plus 2.3 plus 2.3 plus 2.4 plus 3.3. So total weight is 17. So this is how to calculate minimum spanning tree using Kruskal algorithm.
Using Kruskal algorithm method, tourists should use the shortest distance to visit the entry city of Seoul and Bangkok. Otherwise, this method cannot be a loop. I will start with Seoul map. First of all, we need to find the shortest distance. For Seoul map, Bocheon to Guri has the shortest distance which is 0.5 km. Highlight the distance. Next, find the next edges in the graph which smallest which doesn't close the circle, which length 0.9 km. So Anyang to Seongnam is chosen as the second edges. We will repeat by finding the shortest distance and thickening the part used. We must use the same method. Find the value of 0.9 again and see if there is anything it can take if there is no loop. There is no longer a value of 0.9, so we proceed with 1.0. 1.0. There is no longer the value of 1.0, so we continue with 1.1. 1.1 is also not there, so we continue with 1.2. There is another 1.2. Mark it. 1.3. 1.3. There is no 1.3. 1.4. 1.5. Gwamyong to Hanam. We don't take this one because there will be a loop. It would form the loop Guri, Seongnam, Gwamyong and Hanam. 1.6, 1.7, 1.7, 1.8, 1.8, 1.9, no, because it's below. 1.9, 2.0, no, because it's below. Another 2.0 that can connected to Namyangju and there is no loop, so it can be used. The graph contains 10 vertices and 19 edges, so the minimum spanning tree format will be having 10 minus 1 equal 9 edges. Since the number of edges included equal v minus 1, the algorithm stopped here. The next step is to calculate the minimum amount of travel weight taken. Bucheon to Guri 0.5 km. Anyang to Seongnam 0.9 km. Seongnam to Gwangmyeong 1.0 km. Seongnam to Guri 1.2 km. Guri to Seheung 1.2 km. Bucheon to Goyang 1.4 km. Gwangmyeong to Hanam 1.5. Anyang to Incheon 1.8. And the last one is Hanam to Namyangju 2.0 km. We will calculate all the weight to get the total weight. The total weight is 11.5. Okay, let's continue for a map of Bangkok using the same method. This is Kruskal algorithm. First, find the minimum weight. The minimum distance from Payatai to Siam Square is 0.5. Find another 0.5. So there is no 0.5. 0.9 is the next weight minimum. 0.9 from Democracy Monument to Jitlada Palace. 1.0 from the Democracy Monument to the National Assembly Hall. No circle is formed, so we include it. Another 1.0 from Payatai to Victory Monument. 1.0, no more 1.0. Next, 1.1. 1.1 we have Democracy Monument to Chinatown. Then 1.1 Jitlada Palace to the National Assembly Hall, but we don't take it because it's going to be a loop. Next, 1.2. 1.2 for Democracy Monument to National Museum. 1.2 Jitlada Palace to Payatai, 1.2 km. 1.2, 1.2, 1.3, 1.3 from Chinatown to National Museum. We don't accept because this will be a loop from Chinatown, Democracy Monument and National Museum. 1.3, 1.3, 1.4, 1.5, 1.5, 1.6, 1.7, 1.8, 1.9 Chinatown to Memorial Bridge. The minimum spanning tree format will be having 10 minus 1 equal 9 edges. The last one is Siam Square to Lumpini Park, which distance 2.0. The next step is to calculate the minimum amount of travel weight taken using Kruskal algorithm. We start with the small value. First is Payatai to Siam Square 0.5 plus, and then Democracy Monument to Jitlada Palace 0.9 plus 1.0 Democracy Monument to National Assembly Hall 1.0, and then Payatai to Victory Monument 1.0. Plus 1.1 Democracy Monument to Chinatown 1.1. Democracy Monument to Chinatown 1.1. We have 1.2 Democracy to National Museum. (1.2) and then Jitlada Palace to Payatai. Jitlada. Palace. One point two. 1.9 Chinatown to Memorial Bridge. Chinatown to Memorial Bridge. 1.9. And the last one, Siam Square to Lumpini Park. Siam Square to Lumpini Park. 2.0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We will calculate all this. 0.5 plus 0.9 plus 1.0 plus 1.0 plus 1.1 plus 1.2 plus 1.2 plus 1.9 plus the last one is 2.0. The total weight is 10.8.
For this graph, we have to find the minimum spanning tree using Ruskal algorithm. Let's get started. So, which is the smaller edges in this graph? This is the smaller edges, which is 1.0 km. So, I will connect two vertex Yarra Park to Olympic Park. Next, we have a minimum edges here, which is 1.2 km. So, I will connect two vertex Olympic Park to city center. Then we have a minimum edges here, which is 1.4 km. So, I will connect two vertex Yarra Park to Royal Botanical Gardens. We cannot use these edges because it will form a loop. So we will ignore it. Next, we use a minimum edges here, which is 1.5 km. So I will connect two vertex city center to Flagstaff Garden. Next, we have minimum edges here, which is 1.6 km. So I will connect two vertex King Domains to Royal Exhibition Buildings. Also, we have minimum edges here, which is 1.7 km. So I will connect two vertex Royal Exhibition Buildings to Fitzroy Garden. Then we have a minimum edges here, which is 2.2 km. So I will connect two vertex Royal Exhibition Buildings to Melbourne Museum. Also, we have a minimum edges here, which is 2.2 km. So I will connect two vertex Melbourne Museum to Government House. Since all the vertex are covered, we do not need to present remaining edges. So this is the minimum spanning tree. Now we make a table to calculate all edges. Enter the name of vertex and their value. Then we add all values to get weight. So 1.0 plus 1.2 plus 1.4 plus 1.5 plus 1.6 plus 1.7 plus 1.8 plus 2.2 plus 2.2. So total weight is 40.6. For this graph, we have to find the minimum spanning tree using Ruskal algorithm. Let's get started. So, which is the smallest edges in this graph? This is the smallest edges in this graph, which is 1.0 km. So, I will connect two vertex Palace Stage Park to Royal Gallery. Next, we have minimum edges here, which is 1.2 km. So, I will connect two vertex Royal Gallery to City Centre. Then we have a minimum spanning edges here, which is 1.4 km. So I will connect two vertex Palace Stage Park to Timah Castle Gate. We cannot use these edges because it will form a loop. So we will ignore it. Next, we have minimum edges here, which is 1.5 km. So I will connect two vertex City Centre to Melawati Lake. Also, we have minimum edges here, which is 2.4 km. So I will connect two vertex City Centre to Harum Manis Store. Next, we have minimum edges here, which is 2.6. So I will connect two vertex Padang Besar to Sugarcane Plantation. Then we have minimum edges here, which is 3.0 km. So I will connect two vertex City Centre to Homestay Paya Goreng. Then we have a minimum edges here, so I will connect two vertex Sugarcane Plantation to Kuala Sanglang. Also, we have minimum edges here, which is 4.3 km. So I will connect two vertex Kuala Sanglang to Homestay Paya Goreng. Now we make a table to calculate all edges.
enter the name of a text and their value. Then we add all value to get a weight. So 1.0 plus 1.2 plus 1.4 plus 1.5, 2 plus 2.4 plus 2.6 plus 3.0 plus 3.7 plus 4.3. So total weight here 21.1.
Why is minimal spanning tree important? The first one is they can be computed quickly and easily, and they create a sparse subgraph that reflect a lot about the original graph. For the second one is they are also used to find approximate solution for complex mathematical problems like the traveling salesman problem.